Generative AI has the potential to assist people with completing various tasks across different domains. However, despite their capabilities, GenAI tools require time to generate responses, often produce uncertain outputs, and demand additional effort from users to make further edits and correct mistakes. As a result, the use of GenAI support tools does not always guarantee improved productivity. In our paper, we explore how and how well users make decisions on whether to use or not use automation to maximize their productivity given varying waiting times and output quality. We recruited 508 participants to complete a series of paint by numbers tasks, simulating the type of tasks that users could complete on their own, but with which GenAI could also offer assistance. To complete the tasks manually, users use arrow keys and mouse to navigate the grid and fill in colors through pressing the associated number keys. To simulate a GenAI tool, we offered participants an assisted fill tool, which varied in error rate and latency, requiring participants to fix any mistakes made by the tool. We assigned participants to one of 15 latency conditions, ranging from 0 seconds to 210 seconds, and one of 16 error rate conditions, ranging from 0% error rate to 75%. After some practice rounds, participants were asked to complete 2 paint by numbers tasks, one with manual fill and one with assisted fill with their assigned condition. Before task 3, we first informed participants that a new assisted fill tool is assigned to them, but whether they will be using the tool depended on their answers to 2 questions about their tolerable waiting time and error rate. The 2 questions were customized based on participants' assigned assisted fill condition in the first 2 tasks. The first question is for assisted fill tools, if the error rate is always their previously assigned error rate condition, but the wait time can vary between 0 to 210 seconds, what is the longest that they would be willing to wait? And the second question is, if the waiting time is always their previously assigned condition, but the error rate can vary between 0 to 75%, what is the highest error rate that they would be willing to use for the assisted fill tool? Based on participants' completion time for task 1 and 2, we were able to calculate their optimal answers and compare them with their actual answers. We observed gaps between users' actual choices and their optimal choices and characterized these gaps as the gulf of impatience and the gulf of overreliance. The former refers to when participants choose to complete the task manually when choosing automation could lead to faster completion. And the latter refers to when participants should be choosing manual fill to complete the task faster, but they chose automation instead. Combining the results, we locate the gulf of impatience and the gulf of overreliance across all latency and error rate conditions. We found people making optimal decisions when assisted fill is either high performing in both latency and error rate or low performing in both. However, the gulf of impatience occurs when the AI's performance becomes moderate. The gulf of overreliance occurs especially when one of the 2 conditions is extremely good and the other is bad, which is indicated through the dark blue color on the top left and the bottom right corner of the graph. Based on the results, we discussed design directions and opportunities for better human-Gen AI collaboration. We see value in facilitating interaction beyond merely presenting AI's performance. More specifically, we suggest collecting user performance data so systems can calculate and respond to individual behavior patterns, leveraging UI design techniques to calibrate impatience and overreliance, and designing for non-blocking AI in suitable scenarios to avoid suboptimal decisions. Given the increased interests in leveraging GenAI support tools in various tasks, our work illustrates the possibility of creating a controlled environment for systematically testing specific variables representing characteristics of GenAI and revealed key patterns in how users make or fail to make optimal decisions when choosing to use or not use automation that simulates GenAI support tools.